Today I am going to talk about ordinary least square or OLS. OLS is in fact one of the most extensively and widely used econometric tools. So the OLS attempt to solve the regression problem by making the assumption that the dependent variable is a linear function of the independent variable. So OLS is a method for estimating the unknown parameters in a linear regression model. We can say in simple sentence. So the estimator is consistent when the regressors are exogenous. This is very important. It is most efficient if the regressors are exogenous, but if you have any endogenous variable in the model, then OLS will obviously produce biased estimation of results. Also, it is consistent if there is no perfect multicollinearity. OLS are also unbiased estimators when the errors are homoscedastic and serially uncorrelated. So what is homoscedasticity? So I will upload another video on that concept, the homoscedasticity and the heteroscedasticity, because it's an important issue, and I will discuss in a separate video. So I am leaving it here. Here is a classical linear regression model. We can see the different components of the classical linear regression model. That y here is dependent variable. Here the intercept beta 0, beta 1 the slope coefficient, and the x is independent variable, and here the random error. And the figure here also shows the relationship between the different components of a linear regression model: the dependent variable, independent variable, and the residuals. One of the important things I discovered in the last couple of years that unfortunately the OLS technique is frequently misused and misunderstood. So I have prepared this checklist because part of the difficulty lies in the fact that a good number of people are using OLS in their research because they know how to use it. This is very straightforward. If you know the any statistical software, if you are familiar with the statistic, you can write you a estimate the model. But the difficulty is they do not know where it should not be applied. This is very important, rather giving emphasis on how to apply it, because there are some special circumstances where you cannot use OLS, and if you use, then it will produce biased results. So this is the important issue here. So the first one is you have to ask, is the model supported by the sound theory? This is very important. If you include some variables which is not theoretically justified, then it doesn't make any sense. You will also need to ask how well does the estimated regression fit the data. It is also important to ask, is the OLS best estimator to be used for the model, or there are some other options. It is also important to ask how well do the estimated coefficients correspond to the expectations. Are the obviously important variables included in the equation? This is also important. If you miss any variable, then you cannot claim any causal relationship, or you are in fact omitting some important variables and omitted variable bias. So it is also important to ask, has the most logical functional form been used, and does the regression of appear to be free of major econometric problems such as endogeneity I have mentioned here. If your independent variable is correlated with the error term, then it will produce biased results. So you have to check this. So let us see how can we estimate OLS using any econometric software. So I am using EViews here again. So I am creating a work file. Data is unstructured, and I am using my personal data here from my doctoral project. So I am creating a work file with 754 observation. So now I am importing the data from my Excel file. Now we are estimating the equation using the OLS. Here is a list of variables. Because I am not typing it, I am copying it because it will save some time. Then for example, here I want to see how per capita food consumption expenditure of the household is correlated with the household's socioeconomic factors. So the dependent variable is per capita food consumption expenditure. Constant, then gender of the household head, age, education of the household head, dependency, family size, remittance income, non-remittance income, farm size, location specific, a dummy variable for the location. So we are setting the estimation as to least square, and we are running the regression. Here is the output file. EViews produces a dependent variable, the coefficient of different variables, then the standard error, t statistics, then the probability value. We can see most of the probability values are significant at 1% level except age, education, and dependency. Here is the R-squared value. And what does it mean, the coefficient and the what does it mean, the R-square value? What does it indicate? What is F statistics? What is probability of F statistics? Then what is Darwin versus stat, T stat? And also how can we use these results in our paper? For example, here is one snapshot from my PhD thesis, and I presented the estimated results here. What are the norms, principles to present the findings in the paper, and how can we interpret the coefficient, the R-square value, and what are the other specification tests or robustness tests. I'll talk about these issues in detail in part 2. Thank you very much for watching.